Okay, so what we need to do now is we need to finish filling out the unit circle. We've talked about how to fill in the degree measurements of the unit circle and the radian measurements of the unit circle. Now we got to talk about these outside. These are points on the unit circle. So to help us with that, we need some way of measuring some stuff. So we're going to create some little tools for measuring. And these tools are called special right triangles. Special right triangles. And there are two of them. The first one we are going to talk about is called the 45, 45, 90 special right triangle. It's 45 degrees, and 90 degrees. And it'll look something like this. If I can draw a triangle straight. Not really, but that's okay. Let's just pretend. Okay, so 45, 45, 90. So one angle is 90 degrees, and the other two angles are 45 degrees. What that means is if two angles are the same in a triangle, then their opposite sides have to be equal too. Whatever this length is has to be the same as this length right here, okay? So in this special right triangle, and we can make the sides, start off with however big we want. I want to make this one a 1. The hypotenuse of my triangle is 1. So if the hypotenuse is 1, what are the other two side lengths? Well, let's see. If we know these two sides on this side and this side are the same, so I can use an x to represent this side, and I can just use an x because it's the same value to represent this side. I can use the Pythagorean theorem to solve for x. We've got x squared plus x squared is equal to the hypotenuse squared. So x squared plus x squared is 2x squared is equal to 1 squared, which is 1. I can divide both sides by 2, giving us 1/2. X squared equals 1/2. I can take the square root of both sides, so I have the square root of 1/2. So one of the properties I can do with square roots, if I'm taking the square root of a division problem, it's the same thing as taking the square root of the numerator and the square root of the denominator separately, like that. X equals the square root of 1 over the square root of 2. Well, the square root of 1, we can simplify that. That's just 1. And the bottom is square root of 2. So this is the length of those two sides right there. It's 1 over the square root of 2. If you were to type that into your calculator, you get roughly 0.707. Okay, that's what that value is. Now, there is one tiny quirky thing us math people, for whatever reason, don't like. We don't like having square roots in the denominator. Way back when, before calculators, it was very difficult to divide by a square root. Having a square root in the top was okay, but having a square root in the denominator made for really bad, long division and stuff like that without a calculator. So what we want to do is I want to have another way of representing this number so it still is equivalent to 0.707, but it looks different. Now, the only way I can think of doing something like that where I keep the same value is by multiplying by the number 1. That's really the only way you can do it. Like 1 over square root of 2 times 1, I stay at 0.707. So I've achieved one of my goals. I kept the value the same, but it didn't change the way it looked. So what we're going to do is we're going to be sneaky. We are going to multiply by, so I've got 1, let me do this, x is equal to 1 over square root of 2, and we are going to multiply by the square root of 2 over the square root of 2. Now the square root of 2 over square root of 2, that's still equal to 1. I'm still multiplying by 1, so this thing should still equal or be close to 0.707, right? But it's going to look different now. When I multiply two fractions together, I multiply the numerators together. We get square root of 2 times 1 is the square root of 2. And the square root of 2 times the square root of 2, that's the same thing as the square root of 2 squared, because I'm timesing it, right? Square root of 2, see, I'm running out of room. Square root of 2 squared. Well, if I square a square root, those cancel out, and I'm left with just 2. So the square root of 2 times the square root of 2 is technically the square root of 4, and the square root of 4 is 2. If you type this into your calculator, square root of 2 over 2, you get this exact same value, 0.707. So 1 over the square root of 2 and square root of 2 over 2, they are the exact same number. They just look different. It's kind of like if I had 1/2 and 3/6. Those are the same number. It's just we consider this one to be the simplified version and 3/6 as the unsimplified version. It's kind of the same thing here. These are the same numbers. This is the standard or simplified version, square root of 2 over 2, and that's the unsimplified version. Okay, so to recap here, we now know that x is equal to the square root of 2 over the square root of 2. So I'm going to come back here. We're going to write that down. Square root of 2 over square root of 2, and this side is also square root of 2 over square root of 2. That is our first special right triangle. All right, so I cleared out all that work down here, so it's a little bit nicer looking here. The next thing we want to look at is the other special right triangle. This is called a 30, 60, 90 triangle because it's got a 30-degree angle, a 60-degree angle, and a 90-degree angle. Okay, and it's going to look something, well, actually, I'm going to start off with something that doesn't look like that. I want to start off with an equilateral triangle, actually. So I'm going to start off with an equilateral triangle as best as I can draw one. That is not too shabby, actually. Bam, it's pretty good, except for that little corner right there. Looks pretty good. Okay, so I have an equilateral triangle right here. All sides are equivalent, and so are all the angles. The angles are all the same length as well. So let's start with the angles. If all three angles are the same length, then they have to add up to 180. 180 divided by 3 is 60. So each of these are a 60-degree angle. Okay. For our purposes for this triangle, we're going to make each side length equal to 1. So this side's 1, this side is 1, and this side is 1. And our 30, 60, 90 triangle actually comes from half of this triangle. So if I were to take this triangle and split it right down the center, like so, and make this a 90-degree angle, this guy right here is our 30, 60, 90 triangle. In fact, I'm just going to keep this picture right here, but I'm going to just draw that again over here. I've got that little side right there, comes out like so, like that. So we got our 90. This is 60 degrees, okay? And this angle up here, it's half of 60, so it's got to be 30 degrees. This side length right here is 1, as we can see right there. This side length over here is, the whole thing's 1, and we cut it in half, so this is 1/2. And now the question is, how big is this side right here? We don't know, but we can use the Pythagorean theorem to figure it out. So we've got x squared plus 1/2 squared is equal to, equal to 1 squared. So let's simplify this. X squared, 1/2 squared is 1/4. 1 squared is 1. If I subtract 1/4 from both sides, so 1 is really 4/4, and I subtract 1/4, I get x squared is equal to 3/4, right? 4/4 minus 1/4. And then I can take the square root of both sides, and I get the square root of 3/4, which we learned before is the same thing as the square root of 3 over the square root of 4. Can't do anything about the square root of 3, but I can do something about the square root of 4. So square root of 3 over square root of 4 is 2. And I like this number. This is a simplified version. There's no radical in the bottom, so we're good to go. So that missing side right there, this side right here is, let's get our little eraser out. That side right there is the square root of 3 over 2. So this is our special 30, 60, 90 right triangle. The hypotenuse is 1, the short side is 1/2, and the long side is square root of 3 over 2. Our special 45, 45, 90 triangle, the hypotenuse is 1, and both sides are equivalent. The two legs are equivalent, and they're both square root of 2 over 2. So now, why do we care? All right, so here's what I'm going to do. I'm going to kind of erase all this. Don't worry, we'll bring them back up again. Let's erase all of that too. Okay, so now we're back at our circle right here. Okay, so let me pull up our special right triangles. Here they are right there. This is our 45, 45, 90, and our 30, 60, 90 special right triangles. Okay, so this unit circle, the reason why it's called the unit circle is it fits on a XY coordinate axis. In fact, just up here in the corner, I'm going to draw it. So if I have a y-axis and an x-axis, so this is x, this is y. Okay, so let's put some tick marks on there, like so. Like this is +1, +2, right? +1, +2, -1, -2, -1, -2. So, right? So that's a coordinate grid. Okay, this circle right here fits right here in the center, just like that, right there. So the origin, that's the middle of the grid, is this point right here. That's the origin right there. These points right here are points on a grid, and that's what these are. These are parentheses and a comma. These are coordinate points. So let's start with some of the easier ones. We'll color code these. So let's start with this point right here. Okay, there's the origin. So here it is. It corresponds to that point right there, which is 1 on the x, 0 on the y. So 1 on the x, 0 on the y. This point right here corresponds to that one up there, which is 0 on the x and positive 1 on the y. This point right here corresponds to that point right there, which is negative 1 on the x and 0 on the y. And this 270 down here, that corresponds to this guy right there. I guess I should fill in the dot, right? And that is what? 0 on the x and negative 1 on the y. Okay. Now these other dots, like these three right here, let's just mark them really quick in like bright blue. So these 3 points right here, where they're out on this grid is like right here, which are not at nice little spots. And I'm sorry, this is so small, this little grid. So if I have, lines right here, right, the coordinate grid system or whatever, right, those 3 dots are inside of a nice box. They're not on what are called lattice points, where those little nice crossing spots. So it's like, crap, what are these numbers? What are they supposed to be? Well, that's what our special right triangles are going to help us figure out. Let's start with this dot right here. Now I'm going to erase, so this is a 30-degree angle. I'm going to erase the angle measurements just so I have some room to write. Okay, so I'm just going to get rid of those so I have some room to write. This first one is a 30-degree angle. We're going to take this special right triangle right here, and I'm going to lay it up right on top to that point. So what I'm going to do is I'm going to put the hypotenuse of my special right triangle right there on my radius of my circle. Okay, right on the radius of my circle. In fact, let me erase these other 2 dots right there. I don't want them on there. Okay, next, I want to put one of my other sides of the triangle on the x-axis. Always have one on the x-axis and always have the hypotenuse on the radius. So this side right here is going to go right like so. Just color coding it so you can kind of see the orientation of this triangle. And like so. Do you see our right triangle right there? So here's our right triangle. If you'll notice, this angle is 30 degrees. Okay. This measurement of the red side right here is square root of 3 over 2. I don't know why I needed to outline that. That's okay. Square root of 3 over 2. And the green side right here is 1/2. Okay. So there's my special right triangle. And you also remember my hypotenuse is 1. Okay, so this circle fits on this grid. And I'm looking right about there, right? Something like that. Now, the radius of this circle is 1 everywhere. So from the center all the way out here to 1, 0, this length right here is 1. Not the red length, but the length all the way to this pink dot. And it doesn't matter which radius I choose, those lengths are always equal to 1, which is why we wanted the radius of our triangle on that, because it's also equal to 1. So let's think about this. From the origin, if I want to get to this coordinate point, right, I need to go on the x-axis, along the x-axis, square root of 3 over 2. That's this distance right here. I need to go to the right, square root of 3 over 2, and I need to go up 1/2. That's my x distance. This is my y distance. So my x value for this point is square root of 3 over 2, and my y value of that point is 1/2, just like that. So we use this as kind of a little ruler, a little measure to help us figure out what this point is. Okay, let's try the next point. So this time we've got this, it's a 45-degree angle. So if I put this little, so right from there, that's going to be a 45-degree angle. Let's get another couple of colors. Let's see, what should I do? We'll do the same ones. So we've got right to here. That takes me to that point. And then, I did the red one instead of green. That'll be confusing. Let's not do that. Let's do green. Green on the Nope, I was right. I did because I'm so sorry. I lost my mind. Actually, what happened was I accidentally used my pen tool to pause the video, and my drawing application did not like that in the least. So I had to reload the drawing application. Fortunately, everything's still here. Okay, so now I've got this triangle right here. This is a 45-degree angle, so I'm going to use this special right triangle. So just so I have everything lined up, I guess I should have done this in a light blue, but that's okay. There we go. So this is the hypotenuse, and so I line that up right there. Okay, and here, doesn't matter, they're both the same size, so I'm just going to put the red line right here. That's going to match up to this one right here. Okay, so now, to go from the origin to this point right here, I go over this amount, which in our picture is square root of 2 over 2, and I go up this amount, which is also square root of 2 over 2, which means the coordinate point right here is my x value is square root of 2 over 2, and the y value is square root of 2 over 2. Let's try the next one. This time, we've got we're at the 60-degree angle mark, right? So I'm going to use the 30, 60, 90 again. Except for this time, instead of having the red side be along the x-axis, I should have used different colors for the 45, 45, 90. That's okay. I'm going to have this green side be the x-axis. And then that goes right like so. Okay. So the green side here is 60 degrees. So this side length is 1/2. So my x value, to get to this point, I go over 1/2, and I go up square root of 3 over 2. Okay, so let's try another one. So if we come over here to this one, remember, we want to keep one side always on the x-axis, and we want the hypotenuse on the radius right here, right? So this is going to be, always keep one side on the x-axis, like so. And there's my vertical side. So this is, once again, the 30, 60, 90 triangle. My color coordinating on this is horrible. I'm sorry. But this is a 30, 60, 90 triangle. So this is also, this right here is a 60-degree angle that we formed right there. So to go from the origin over to this point, I go to the left 1/2. Now remember, this is on a grid system. So if I'm at the origin and I move to the left, that's a negative value on my x. So really I'm going negative 1/2 and then positive square root of 3 over 2, because I'm going up square root of 3 over 2. That's that length right there. Positive square root of 3 over 2. Okay, the next one, just erase that. We've got our hypotenuse, right? So here's our hypotenuse. Yoink, like so. And I'm going to be different. Let me just put a darker blue on this. I don't like those using the same colors. All right, so that would be square root of 2 over 2, square root of 2 over 2 in dark blue, so it's not the same color. Okay, so I go over the same amount I go up, which means we're using the 45, 45, 90 triangle. So the hypotenuse is 1. Going over here, we're going to the left again, square root of 2 over 2. And we're going up square root of 2 over 2. Now remember, we're going to the left, so this should be a negative square root of 2 over 2. In fact, if it helps, think about the quadrants on the coordinate system. This quadrant in the top right is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. You notice it's the same order we go in with our angle measurement. So if I pull up the degrees again, right, we're going in a counterclockwise order, right? Same idea there. So anything in quadrant 1, any of these points in quadrant 1, they're both positives. X is positive, Y is positive. In quadrant 2, your X is negative and your Y is positive. Quadrant 3, they're both negative. And quadrant 4, X is positive and Y is negative. So that will help you maybe with the negative signs and stuff like that. Let's do the next one. Get our radius, which is the hypotenuse of our triangle. This doesn't look like a 45, 45, 90, so here we go. We've got this side length, the bigger one, and then we go up the little amount, right? So we go to the left, the large amount, square root of 3 over 2, so that's negative square root of 3 over 2, and we go up positive 1/2. Okay, the next one, let's just erase all this stuff. It's just kind of in the way. Down here, wow. That was really bad. Okay, let's try this again. Like so. We've got the long edge along the x-axis, and we have the short edge going down. So the long edge is the bigger number, square root of 3 over 2. We are going to the left, so that is negative square root of 3 over 2. And then we are going down 1/2, so that's negative 1/2 on the y value. Remember, this is a y value, so negative square root of 3 over 2, down 1/2 is that point right there. Then I think we can probably do the rest of these without drawing our triangles. The next one's going to be one of my 45, 45, 90s. So I know they're both square roots of 2 over 2. Okay, and I go to the left, so that's negative, and then I go down, that's also negative. So these are both negative square roots of 2 over 2. The next triangle, I go over just a little bit, comparatively speaking, to how much I go down. I go over a little, down a lot. So over is a little is a smaller number, so negative 1/2. Down a lot, so that's negative square root of 3 over 2. Then over here, I go to the right a little, that's the 1/2, and it's positive because we're moving to the right. And then I go down a lot, that's the big side, so I go down negative square root of 3 over 2. The next one's a 45 angle. It's right down the middle, so it's 45. So they're both square roots of 2 over 2. But say I go to the right, which is positive. I go down, which is negative, so the y value is negative. And then last but not least, we go over a lot. That's the square root of 3 over 2. We go down a little, so that's 1/2, and we are going down, so it is negative. And there are the points on the unit circle. So really, all you have to do is remember these three numbers, square root of 3 over 2, square root of 2 over 2, and 1/2. And I just like remembering that the square root of 3 over 2 is the bigger one. Square root of 2 over 2 always goes with itself, right? They're always on those 45s. They always go with themselves. 1/2 is the smaller number. So if I'm thinking, okay, I want to get to this point right here, I go over a lot, that's the big number, square root of 3 over 2, and I go up a little, that's the 1/2. So I went to the left, so that's going to be a negative square root of 3 over 2, up a little, which is positive 1/2, which is that coordinate point. And that, if we throw in the degrees and radians, all of that stuff is the unit circle.